microphone. Okay, so we just did 12.2, which is permutations, and now we're going to jump into 12.3, which is combinations. Permutations, if you remember, is when the order matters, and we have P of n choose R, which is the same as little n, big P, little r, and that's the same as n factorial divided by n minus r factorial. Okay, so remember, permutations is when order matters, such as when we're arranging books on a shelf, forming codes, seating arrangements. Remember, we had circular permutations. And today we get combinations. You're going to see that things are a little similar as far as notation is concerned. We have the combination of n choose r, or little n, big C, little r, and this is when order doesn't matter, okay? So permutation is when order matters. Combination is when we don't care about the order. Okay, so such as choosing students to serve on a committee. Well, they're serving on a committee, but I don't really care which order they come in. Or drawing cards from a deck. Or the lottery, right? Order doesn't matter. We want the right numbers. Well, our numbers, so we can win millions of dollars, but it doesn't matter how we get those. Okay, so sample or example 1. Given the letters A, B, C, and D, we need to A, find the number of ways to arrange any 3 of the letters to make code words. This is a permutation. Okay? It would be, well, I have 4 options, then I have 3, and then I have 2. So it was 4 choose 3. And we would write that as 4 factorial over 4 minus 3 factorial, just using our permutation. And this is a permutation because it's a code. Order does matter. Well, now we want to find the number of ways to grab any 3 of the letters, and we don't care about the order. This is a combination because we don't care about the order. Now write the different ways to get any 3 letters where order does not matter. They give you a couple, A, B, C, A, C, D. I'll throw in a few more. Maybe B, A, C. Okay. Or D, B, C. Yeah. What about you? Did you find any others? Don't answer because I'm not going to respond. I'm not going to hear you. But you might have, and that's okay. Since order doesn't matter, and each set of 3 letters can be arranged in 3 factorial ways, we take the answer from part A, okay, so that was our permutation, and divide out the number of ways to order the 3 letters. That is, divide by 3 factorial. So we take this and divide by 3 factorial, and we end up with this fancy, fancy little formula. This is our formula for combinations, okay? Some people prefer to read it and choose R, which you've heard me say in class. If I have 5, choose 3, that means I have 5 total elements, right? But I'm only going to choose 3 of them. The formula, which again will seem very similar, is the total number of elements to choose from is our little baby n. The little r is the number of elements we're actually choosing. The only difference is now we have a C because we're dealing with combinations. And then this looks super familiar. If I cover that up, well, we have our permutation. But since it's a combination, I need to account for that r factorial. Okay? Don't forget, order doesn't matter. Order doesn't matter. Now, we also have this button in our calculator. We have our permutation. If you turn your calculator on, and I'll show you in just a second, and you go over to math, right? And we arrowed over to probability. Well, we have that same option for combination. So turn your calculator on, go to math. If you arrow over to probability, oh, whoops, oh, don't do what I just did. And go down, there is our combination. So it's right between the permutation and the factorial. Okay, and that's going to work the exact same way, and I'll show you as we get through some of these problems. So let's do some. Number 2. There are 85 teachers at a school. 3 are needed to serve on a committee. In how many ways can the teachers be selected? Well, if you remember back at the top of your notes, serve on a committee. I don't really care what order. So I know right off the bat, besides the fact that it is in this section, that it is a combination. The total number that I have is 85. So that's my n. and I need to choose 3, because I only need 3 to serve on my committee. I can also write that as C of 85, choose 3. I can also write that as 85 factorial over 85 minus 3 factorial times 3 factorial, just using the combination formula. Take what I know and plug it in. Okay, well, let's say that you're calculator dependent, like most of you are. I'm going to go ahead and put in 85, because that's my total number of elements. Go to math and arrow over to probability. Go down to N, choose R for combinations. And I'm only choosing 3. Well, there happens to be 98,770 different ways that I can choose this. Now, what about number 3? How many telephone lines are needed to connect 15 towns if there is exactly one line connecting any 2 towns? Well, think about that. I know that I have 15 lines, or 15 towns, right? Okay, so we have 15. It's a combination, because I don't care what order, but one line connects how many towns? It connects 2. So I have 15 towns, choose 2. So I have C, 15, choose 2. If I put that into my calculator, I'm going to have 15 math, arrow over, down to 3. And I'm choosing 2. I need to connect 15 towns, but I'm going to choose to connect 2 at a time. How many ways can I do that? Well, I have 105 different ways I can connect those towns. See, this isn't so bad, right? Yeah, sure. Okay, number 4. How many 5-card hands can be dealt from a standard deck of 52 cards? Well, how many cards do I have in a standard deck? Well, they tell me I have 52. Okay, so I'm going to have 52 cards, and I need to choose 5. And I want to know how many different ways I can do that. Order doesn't matter, so this is a combination. And I have the combination of 52, choose 5. Well, if me and Miss Brady makes you write it out, it's going to be 52 factorial of 52 minus 5 factorial times 5 factorial. Put it in your calculator. We get 52 math, arrow over to probability, and we're choosing 5. There is where are my parentheses? There we go. 2,598,960 different ways that we can choose a 5-card hand. So 2,598,960 different ways. Pretty ridiculous, huh? All right, number 5. How many 5-card hands having 4 hearts and 1 club can be dealt from a 52-card standard deck? Okay, there's 3 different things they're asking for. I need to know how many 5-card hands, how many times can I get 4 hearts, and how many times can I get 1 club. 3 different combinations. The first one we know is 52, choose 5, and I'm going to multiply this. Well, there's 4 different suits. There's clubs, spades, hearts, and diamonds. And each suit has 13 different cards. So out of 13, I want to choose 4. But I have one more condition. I need 1 club. And there's 13. Remember, there's 13 suits. Club is one of them. 13, choose 1. And I want to know, what are the odds? How the heck am I going to get this? How many different ways? So I'm going to put in the first one, which is 52, math, choose 5, times 13, math, over to probability, 4, times 13, choose 1. 2.42 e to the 10. What does that mean? What the heck does that mean? That means, my friends, that we are talking about scientific notation. So I'm going to rewrite this as 2.42 times 10 to the 10th power. And I would accept that on a quiz or a test. That would be fine. If you wanted to move the decimal 10 spaces and give me the big number, that is fine also. It's completely up to you. Number 6. How many diagonals does a regular octagon have? Well, right away, octa should make you think, ooh, there's got to be 8. So I'm going to draw my octagon. Let's not make fun of my drawing. If you do, I'm never going to know. Okay, so there's my octagon. And how many diagonals? Well, please remember that a diagonal goes from one point to another. So I have 1, 2, 3, 4, 5, 6, 7, 8 points. 8 points, and I'm going to choose to connect 2 of them. I want to know how many different ways I can do that. Please keep in mind, we also need to account for the line that connects these 2, the line that connects these 2, the line that connects these 2, and I have 8 of those. My calculator doesn't know that I'm saying I only want the diagonals. It thinks I'm trying to figure out ways to connect every point regardless of how I do it. It just has to be a straight line. So in order to account for that, I'm going to find what this is and subtract those 8 lines that are not diagonals, but they connect the 2 points. Okay? So putting it into my calculator, I'm going to have 8 math. Choose 2. Figure out what that is. It's 28. So there's 28 ways, but I have to account for those 8 that are not diagonal, so I subtract it, and there's 20 different ways, or 20 different diagonals, I should say, that a regular octagon has. Seems a little crazy, huh? All right, number 7. I have 8 teachers and 7 volunteers that are students to serve on a committee needing 3 teachers and 2 students. Well, how many ways can I pick that committee? It's a committee, order doesn't matter, but I'm dealing with 2 different groups. Similar to number 5, where we had a deck of cards and we had different how should I say this? We'll go with specifics that I was looking for in that hand. Well, the first one, I know I have 8 teachers, and I want to choose 3 for my committee. That's all I want. And then I have 7 students, but I really only need 2. Okay, similar again to number 5, I'm going to multiply my 2 possibilities together. So, pardon me, I have 8 math, go over to probability, down to my combinations. 8, choose, we wanted 3, times 7 math, over to probability, whoops, choose 2. There are 1,176 different ways that I can choose my committee. And last but not least, I have a bag containing 10 black marbles and 8 orange marbles. How many ways are there to draw 3 black marbles and 6 orange marbles from the bag? Order doesn't matter. That's huge. If order doesn't matter, that means that I'm dealing with a combination. But I have 2 different things. I need to, from 10 marbles that are black, choose 3. And from 8 marbles that are orange, I need to choose 6. Just going to multiply them together. That's it. So in my calculator, I'm going to put in 10, go to math, over to probability, choose 3, and I have 8 orange marbles, and I need to choose 6. So there's 3,360 ways that I could choose my orange and black marbles because order doesn't matter. If order mattered, it would be a much, much smaller number possible ways that I could do it. Okay, so now, my friends, enjoy homework number 3, and I will see you guys either Thursday